In order to improve hurricane forecasts, scientists model storms of the past.
We model old storms because it gives us a way to compare the simulations to observations and try to assess the physical processes within storms, and also how well those processes are represented in the forecast models, because that's key to improving forecasts in the future.
With improvements in computing power, researchers have been running ensemble forecasts.
Instead of a single forecast, we run a whole series of forecasts where you make slight variations to the initial information that goes into the models, and then see how much spread you get within those forecasts.
Running ensembles gives us a visual description of the level of uncertainty associated with forecasting tropical storms.
And the average of over all those ensembles usually gives you a better forecast than if you ran just a single forecast model.
One way to test forecast models is to reanalyze past storms.
It's very important to study the worst possible storms in history, because those are the ones that really put the system to a challenge.
NASA and NOAA cooperate in satellite systems and sharing data, as well as experiments and modeling research, all of which enable NOAA and other agencies to provide better forecasts of tropical cyclones.
When NOAA, National Hurricane Center, issues a forecast, the better the forecast is historically, the more likely is that people would trust the forecast, and decision makers will make the right decisions, and they will tell what place has to be evacuated and what place can stay.
To get a clearer look at the processes inside the hurricane, NASA's Global Precipitation Measurement Microwave Imager, or GMI, gives us an X-ray beneath the clouds.
If you have a storm that maybe isn't well defined, doesn't have a visible eye, with the GMI and similar instruments, you're able to see the rainfall structure underneath those clouds. So you can see the ring of heavy precipitation in the eye wall, as well as several of the rain bands. And that really helps to tell us a lot about how the storm is evolving and how that might relate to the intensity of the storm.
Representing those small-scale eye processes in global models has been an ongoing area of research.
By increasing resolution and increasing, of course, the quality of the physical processes representation inside the model, that all global models have been getting better and better. They make hurricanes that are smaller, more compact, closer to the real sides, and the eye becomes smaller and smaller, and they become more intense.